Welcome to the class on electrical machines. In this lecture, we are going to discuss about the starting methods of single-phase induction motor, part 1. Already we know that the single-phase induction motor along with a single winding, there is no inherent starting torque. Since the main winding introduces only the stationary and pulsating air gap. For developing the starting torque, the rotating field is required at the time of starting. So to create the rotating magnetic field at the time of starting, there are several methods are developed for the starting of single-phase induction motor, classified as follows. The starting methods of single-phase induction motor is classified into the split-phase starting method, shaded pole starting method, repulsion starting method, and reluctance starting method. These are the different methods by which we can start the single-phase induction motor. Now first we are going to see the split-phase starting method. In case of split-phase starting method, the stator winding is equipped with two windings. One is the main winding, nothing but a running winding. Another one is the auxiliary winding. Both windings are displaced by 90 degrees in a space. This is the main winding, this is the auxiliary winding. Both are displaced by 90 degrees in a space. So whenever we are displacing these two windings electrically in a space by 90 degrees, if we send the current through the two windings which are time displaced by 90 degrees, then the rotating field will be created. See here how we are going to generate a time displacement current means the two methods are there. The first method is the for the main winding you can apply the one voltage, auxiliary winding you can apply the one more voltage which is displaced by the voltage applied to the main winding by 90 degrees, nothing but a two-phase voltage, then the rotating field is created. But practically the two-phase voltage is not available. We have only single phase and the three-phase voltage. Now here what we have to do is that these two windings are connected parallelly across the single phase supply. We are designing such a way that the impedance of the main winding and auxiliary winding will be different, so that there is some angle between the current taken by the main winding as well as the auxiliary winding. So due to that, the rotating field will be creating at the time of starting, which gives the starting torque to the single phase induction. This phenomenon is nothing but a split phase starting method. Phase starting methods can be divided into the again four types. One is resistance split phase motor. The second one is the capacitor start split phase motor. Third one is the capacitor start capacitor run split phase induction motor. Fourth one is the capacitor run split phase induction. Now in this lecture we are going to discuss about the three motors. The first one is the resistance split phase motor. In case of resistance split phase motor, see here again the stator winding is consisting of two windings. One is main winding, another one is auxiliary winding. Nothing but another name for the auxiliary winding is nothing but starting winding. The main winding is denoted by the M, where the starting winding is denoted by the S. This is the equivalent circuit. This is the starting winding, this is the main winding, this is the centrifugal switch. Whenever the speed of a rotor is reaches the 75% of the synchronous speed, the centrifugal switch will be off. Once it is off, the starting winding will be disconnected from the rotor. This is starting winding, this is the main winding, both are electrically displaced by 90 degrees. So this is the starting winding which is designed such a way that high resistance and low reactance, whereas main winding or running winding is designed such a way that it has a low resistance and large inductance. So consequently, we are applying the same amount of voltage to the both main winding and starting winding at the time of starting. So there is some angle between the starting current and main current that we are going to see here. On the x-axis we have taken the voltage. This is the starting current which lags the voltage by some angle. Main winding current which is lags the voltage by more amount of the angle between the starting current and the motor main winding current nearly equal to the 20 to 30 degrees. So starting the develop single phase induction motor, Ts equal to K into Im into Is sin phi. Here K is nothing but a motor constant, Im is main stator winding current, IS is nothing but a auxiliary stator current. Phi is nothing but a angle between the main stator winding current and auxiliary stator current. This is the graph drawn between the speed and torque developed in a resistance split phase induction motor. See, if you observe from this graph, the starting torque developed in induction motor, this is the point where the slip of the induction motor is 1. Nothing but this value is nothing but a starting torque. At this point, it is somewhat lesser. The application where we are using this type of motors are the washing machines, oil burners, small machine tools. The power rating of motor generally lies between the 60 watts to the 250 watts and flat. Next, we are going to see the capacitor split phase motor. In case of capacitor split phase motor, again the stator is consisting of two windings. One is main winding, another one is the auxiliary winding or starting winding. Both are displaced by 90 degrees in space. Now, in the starting winding, we are keeping a one capacitor in series with a starting winding. This is the centrifugal. We are applying the same voltage to the main winding and auxiliary winding. So whenever we are keeping the capacitor here, whereas the main winding current will lag the voltage. So there is a lot of angle between the starting current and the main current. So the starting torque development single phase induction motor is highly depending upon the angle between the starting winding current and the main winding current. So in this method, high starting torque will be developed in induction motor. So whenever you are applying a voltage to the motor, because these two currents are time displaced, rotating field is creating. Because of the rotating field at the time of starting, the rotor also will be rotating. Whenever the speed of a rotor is equal to 75% of the synchronous speed, then the centrifugal switch will be open. Nothing but a starting winding will be disconnected from the circuit. Now the motor will be running only because of the sinusoidal. This is the phasor diagram where we can see the starting current. This is the main winding current. This is the voltage. Here the angle is nearly. We have taken the capacitance value such a way that the angle between these two currents are nearly the 80 degrees. Now consequently, the starting torque is much higher when compared to the resistance split phase motor. Speed torque characteristics of a capacitor split phase induction motor. If we compare these characteristics with a previous resistance split phase induction motor, the starting torque is very high. The application where we are using this type of motors are since the motor possesses a high starting torque, these motors are used for the refrigerators, air conditioners, compressors, reciprocating pumps. Other loads requires a high starting torque. The power rating of such a motor lies always between the 120 to 750 watts. Third one is the capacitor start, capacitor turn induction. The main disadvantage of the previous motor is that during the running the capacitor will be disconnected, so the power factor of the induction motor will be very less. So to improve the power factor of the single phase induction motor, we are going for the capacitor start, capacitor turn induction. Nothing but in the name itself it is there. At the time of starting of induction motor, we are keeping the capacitor. The same manner during the running also, we are keeping the capacitor in the stator winding. So the power factor of induction motor also will be increases. Not only that, it gives the high starting torque. If you come to the capacitor start, capacitor turn induction motor, there are two types of designs are there. Again, the stator is consisting of two windings. One is main winding, another one is the starting winding. In the first design, the capacitor is always connected in series with a starting winding. So at the time of starting as well as the running also the capacitor is there. So the starting torque is more. Not only that, the power factor of the induction motor also will be improved. Apart from that, it does not require any centrifugal switch. This is the first type of design. In second type of design, the main winding is connected in series to the capacitor C1. So one more capacitor also connected across the C1, that is C2, through this is centrifugal. The value of C1 is designed such a way that it has to give the good power factor to the single phase induction motor. At the time of starting, the switch is closed, so high amount of capacitance is placed in series field winding. This current leads the starting current, so more amount of angle between these two currents, high starting torque will be developed in a induction motor. So whenever the speed of a induction motor is equal to the 75% of the synchronous speed, then the centrifugal switch will be opened. Once it is opened, only the one capacitor is connected in a stator winding of induction motor, so that it gives the good power factor. This motor has some amount of characteristics. The starting winding and capacitor can be designed for a perfect two-phase operation at any load. The perfect two-phase operation is nothing but the angle between the These two currents are 90 degrees. In that manner, we are designing the value of C1 and C2. The motor then produces a constant torque, no pulsating torque as in other single phase motor. Because of constant torque, motor is vibration free. Speed torque characteristics of a capacitor start capacitor run in induction motor. In this motor, the constant torque is developed, so it is a vibration free motor. So we are using this type of motors where the places where the silence is very required even the motor is running. Nothing but a hospital, studios, other places where the silence is very important. Thank you very much. If you have any doubt, you can ask me directly or you can ask in the comment box of my YouTube channel so that I'm always welcome to answer all your